Today we're going to review how to find slope, and we're going to focus on scatter plots. When we are looking at scatter plots, often we just have the points plotted and we do not have a line. So if there isn't a line in our scatter plot, our first job is always to find that line of best fit. And as a reminder, that means that we're looking to go kind of through the middle of our data where we have equal points above and below our line. Once we have our line of best fit, then we can read our line left to right and find our perfect points. And then we can use one of the following strategies to find our slope once we know our perfect points on our line of fit. Lastly, once we calculate our slope, then we're able to put it all together in our equation. As a reminder, when we're writing our equation, we're following that y equals mx plus b format. So when we're looking at this format, we're knowing that the y is representing whatever quantity is on my y-axis. The m is going to represent my slope of my line. So that's where my slope is going to go in. And then the x represents whatever is my x quantity on the line. And then my b at the end is my y-intercept. Okay. So when we're done finding our slope, we will then need to look back at the graph and see where does our line cross the y-axis, where is our line starting on the y-axis, where is our line starting for our line of best fit. The first strategy that we're going to use to find slope is slope formula. We're again starting by finding those perfect points. So when I read my graph, I'm going to start left to right, and I'm going to find my perfect points. So I see I have a perfect point here, and then as I go up, I'm finding those perfect points where my grid lines cross. Once I find those perfect points, slope formula requires me to have my x and my y coordinates. So I'm going to find my ordered pair for each of these. In order for me to find my ordered pair, I will need to look at what my scale is on both my x and my y-axis. In this particular scatter plot, my x-axis is going by chapters, and I can see that it's counting by 2. So that means I can fill in my missing numbers and know that this would be 4, this is 8, this is 12, this is 16, and then lastly would be 20. When I look at my y-axis, which is counting by pages, that one's going up by 20. So then I would have 40 pages, 80 pages, 120 pages, 160 pages, and then 200 pages. So then when I'm looking for my ordered pair, it's easy for me to see what my ordered pair is. So in the case of my first ordered pair, I know that I'm going to have 4 as my x and 40 as my y. My second ordered pair is going to be 8 and 80. My third ordered pair is 12 and 120. I really only need 2 ordered pairs, so I can stop here, but if I wanted to continue, I would have 16 and 160, and then 20 and 200. When we look at our ordered pair and our formula for slope formula, we see that our slope formula is y2 minus y1 over x2 minus x1. And when we're looking at our points, our first ordered pair is x1, y1. Our second ordered pair is our x2, y2. We know the order of those points based on our ordered pairs reading left to right. So my first ordered pair could be 4 and 40, and then my second ordered pair could be 8 and 80, because those are the first 2 ordered pairs I came to reading my line left to right. I then know that this would be my x1, this is my y1, this is my x2, this is my y2. So then when I go to fill it in to my formula, I'm going to start with my format where I know that I'm going to have my fraction and I'm going to have my y2 minus y1. In order to help us, I can use color coding. So I know that my y2 is going to be in this front part, and that's going to be represented by that 80. I know that my y1 is going to be in the second part, and that's going to be represented by my 40. I know that my x2 is going to be represented by my second x, which is my 8. And then lastly, my x1 is going to be the first x, and that's going to be my 4. So once I know those, I can now fill those in with my color coding. So that's going to be 80, 40, 8, and 4. Then I'm going to subtract. So 80 minus 40 is 40, and 8 minus 4 is 4. I then would need to simplify my fraction. In order to simplify, I'm going to look to see what can I divide into both top and bottom evenly, into my numerator and denominator evenly. In this case, it can be 4. 40 divided by 4 is 10. 4 divided by 4 is 1. Anytime we have a denominator of 1, then my slope is a whole number, and my slope would be 10. Since I now know my slope, I can plug that into my equation. And remember, my slope is going to go in this first part. So my 10 is going to go in front of the x as the coefficient. For my second part, that's my y-intercept. So I'm going to go back to my graph and see where does my line start. In this particular case, my line is starting at the origin, which means that it's starting at 0. So I do not have a y-intercept, or I have a y-intercept of 0. So I could either have the equation of y equals 10x plus 0, or it could be written as y equals just 10x. I don't need to have the y-intercept if I don't want it, because it is 0. It doesn't change the equation at all. Okay. So that's strategy 1, using the slope formula. You can use any 2 points on your line as long as they're perfect points on your line. You just have to simplify depending on how your points work. The second strategy I'm going to show you is using a table. So in this particular graph, we don't have our line of best fit drawn in yet. So first thing we need to do is we need to draw in our line of best fit. So we're going to follow the pattern or the direction of the points. In this case, they're kind of starting high as I read and going down low. So as I draw my line, I'm going to draw my line to go through the middle of those points as best I can. And I'm going to go from end to end. So in this case, I'm going to now look for my perfect points on my line, and I'm going to then fill in my table. So I know that I have a perfect point. I'm going to use a different color just so they stand out a little bit more. I have a perfect point up here. And then going down, it looks like I have a perfect point here. I have a perfect point here. And then I have a perfect point here. So those would represent the bulk of my perfect points. So now what I'm going to do is I'm going to put those points into my table, same as we would with our coordinates almost. My first one is going to be my x coordinate, which is my hours. My second is going to be my y coordinate, which is my height. So that first point I have is at 0 hours, 16 height. My second point, as I look at my scale, this is counting by ones, so then this would be 5, 6, 7, so that's going to be at 7. And then this is also counting by ones, so that's going to be at 9. So my ordered pair here is at 7 hours. I'm at a height of 9. My last point comes down here. That would be 1 less than 12, so that's 11. And then going across, it's 1 more than 4, so that's 5. And then my last point is at 16 hours and 0 height. In order to calculate my slope here, what I can do is I'm looking for my change in y over my change in x. So what I'm going to do is I'm going to look to see how is this changing. So as I go down, I'm adding 7. Then I go and I add 4. Then I go and I add 5. It's okay that it's not necessarily the same. If I look here, I'm decreasing. So I'm starting bigger and I'm going down. So I'm subtracting. I have -7. Then I have -4. Then I have -5. I'm sorry. So then with this one, I'm going to pick one of those, and I need to make sure that I choose the same 2 points. So it doesn't matter which 2 points I choose. So in this case, I'm going to choose these points here to calculate my change. So when I look at those change, my change in y is going to be represented by this number there, and my change in x is going to be represented by my change on the x side there. So in this case, my change in y is -7, my change in x is +7, and then I would simplify. In this case, when I simplify, I have the same numerator and denominator, so therefore I know that it's going to be equal to 1 as a whole number, and since I have one negative number, my slope is going to be -1. No matter what 2 points we chose, it would always end up being that -1. So in this case, when I look at my formula, and I look at my equation, my slope is going to go in that first part, so my slope is going to be -1. This one does not start at the origin, so it does have a y-intercept. So we do want to make sure that we're finding that y-intercept, or where my line is starting. So when we zoom in, we saw that we had that perfect point at 16, and we also saw that in our table in this perfect point right here in our top, where we have 0 as my x and my y is 16. So in this case, my y-intercept would be 16. Therefore, my equation would be y equals -1x plus 16, or you could write it as y equals -x without the 1 in front plus 16. Either one would be fine. You don't need the -1 in the front. There's one more problem now that we would like you to try on your own. You can use either the strategy of slope formula or drawing a table and putting your ordered pairs in a table, whatever you prefer. But please notice that you have to first draw your line of best fit, because there isn't a line in our scatter plot, and make sure you're paying careful attention to how our x and our y axis are counting by, since they're not counting by ones, because that's going to be important in our equation when we're trying to calculate that slope.